Hey, welcome back, guys, to another episode with Destination Pen Tester. Today, we're going to be doing part 4 of the course that we have been working on, which is Metasploit Unleashed. So today, we're going to be discovering and really looking into SNMP walk. So without further ado, let's get into it. All right, guys, so we're in our Kali VM. Let's go to the internet. Let's search for Metasploit Unleashed. Click on the first one that comes up. Let's go down to information gathering. Let's select SNMP sweeping. That must be the one. This is the one. Awesome. So let me make this a little bigger. Okay, so we're an SNMP auxiliary module for Metasploit. So I think that the first thing we need to ask ourselves is, what is SNMP? So SNMP stands for Simple Network Management Protocol, and it's a way for devices to run on a network and share information with one another. It allows devices to communicate even if the devices are of a different hardware and run different software. Cool. So the first things first, right? SNMP is a protocol. It's called Simple Network Management Protocol. So just by the name, we can assume that, okay, there is some management done over it, and there's a way to reach it and communicate with it. But a protocol is just basically a set of rules that tells, it's basically the set of rules that define the language and tell computers how to communicate utilizing that protocol. So without the protocol like SNMP, there would be no way for network management tools to identify devices, monitor network performance, keep track of changes to the network, or determine the status of network devices in real time. Wow, so I didn't know all of this, to be quite honest with you. Actually, SNMP just sounded like, oh, okay, this is something that was used back in the day when technology wasn't as advanced, but it sounds incredibly important, right? Because without SNMP, or without a protocol like SNMP, I don't know if it's been replaced or not, there's no way for network management tools, think of like SolarWinds, for example, to identify devices, or Cisco even, right? So it can identify devices. You can't monitor network performance, you can't keep track of changes to the network, or determine the status of network devices in real time. So SNMP is a big deal, right? It's what allows these computers to communicate with each other, but also for network management tools to get information about the status of the network, about the status of the devices, and other things like that. So SNMP is a protocol that allows for network information to be collected easily. So SNMP architecture. So it's based on a client-server model, meaning the client and then the server. The client makes requests from the server responds to the client. The servers are called managers, and then the client are called agents. So the managers will collect and process information about devices on the network. The agents are on any type of device or device component connected to the network. Okay, so the agents are going to be on every single device in the network. The managers are going to collect and process all of the information from the devices on the network. And I'm sure that the agents have something to do with the collection and the sending of that information to the server. So notice that the devices and the components within the network obviously include computers, but not just that. It can include network switches, phones, printers, and all of that kind of stuff. When we think about networks and we think about IT, we're not really thinking about like fax and phones and printers. We're really thinking about just computers. But, you forget that, yeah, there's other things that can connect to the internet, like printers and phones and things like that, and switches, network components too. So the data hierarchy in SNMP is kind of like a tree. So in the image that you see below, the data is going to be saved in the different branches of the tree, which are actually tables, and these tables are called management information bases. Each MIB, or management information base, has a unique identifying number as well as an identifying string. Numbers and strings can be used interchangeably, just like IP addresses and host names. Each MIB consists of one or more nodes, which represent individual devices or device components on the network. In turn, each node has a unique object identifier, or OID. The OID for a given node is determined by the identifier of the MIB, on which it exists combined with the node's identifier within its MIB. This means that OIDs, or object identifiers, take the form of a set of numbers or strings. Again, you can use these interchangeably. An example is this. So this is what an OID can look like. Written with strings, that OID would translate to this. So notice that this, the number, and the string both point to the same object and are both unique to that object. Using the OID, a manager can query an agent to find information about the device on the network. So every branch is composed of one or more OIDs, remember? And each OID has a unique number and a unique string. So if you want to pull information on, I don't know, system 1 right here, you would have to know its OID. So why use OIDs? The MIB and the OID data hierarchy may seem confusing, but there's several important advantages to it. One is that information can be pulled by the manager without having to send an explicit request for the agent to collect it. That reduces overhead and ensures that information about the network status is always readily available. Got it. Okay. So what they're doing is that instead of having to query all the time, the information is always available because it's always together. Hey baby, say hi to the fans of Destination Pentester.
Oh no! I called you while you were filming.
Yes.
Oops. Okay, well, I'll take this part out of the scene.
I'll probably leave the part where you say, "Oh no." Okay, sorry about that. So there's many advantages to using the OIDs, and it's mainly to have all of the data available whenever the manager needs it without clogging the network because of large data transfers, without slowing it down, having to collect all the data and then present it. So it's always available because of the tree-like structure that exists. And that really summarizes this piece right here. So there are different SNMP versions. So SNMP v1, which is the oldest, obviously this one is going to have some security weaknesses, as we see here. Under v1, managers can authenticate to agents without encryption when requesting information. That's kind of like Telnet and FTP. You could send your credentials to the service, but if an attacker is performing a middleman or a man-in-the-middle attack, then he can sniff your credentials and use them to authenticate himself. In SNMP v2, they offered some security enhancements, but it was quickly supplanted or replaced in 1998 by SNMP v3, which is the most secure and the most recent version. So SNMP v3 makes available data encryption. It also allows admins to specify different authentication requirements on granular basis for managers and agents. This prevents unauthorized authentication and can optionally be used to require authentication transfers. Okay, so I think that we have learned nice bases, so I think we've learned the basics of SNMP, the data, what the OID is, what the MIB is. So now let's go back into the course. All right, so with SNMP auxiliary module for Metasploit. So continuing with our information gathering, let's take a look at SNMP sweeping. SNMP sweeps are often good at finding a ton of information about a specific system or actually compromising the remote device. If you can find a Cisco device running on a private string, for example, you can actually download the entire device configuration, modify it, and upload your own malicious configuration. Often the passwords themselves are level 7 encoded, which means that they are trivial to decode and obtain the enable or login password for the specific device. And when they say that the level 7 is a very trivial to decrypt, there are websites that you can just put the password in. It just looks like a long string that starts with the number 7. You can put it in there and hit click, wait 5 seconds, and then it'll give you the password. It's that easy. It's something to do with the weak encryption standards used for level 7. Yeah, these Cisco devices should not use level 7 at all because it's very easy to decrypt. So let's continue reading. Metasploit comes with a built-in auxiliary module specifically for sweeping SNMP devices. So before we move forward, we need to think again, what are we doing in this section? Why is SNMP important? And why is it important for me to know that, okay, Metasploit has SNMP and I can do things with it? Because remember, we're in the information gathering stage. So in this stage, we probably know little to nothing about the target. If SNMP is available and if we're able and if it's vulnerable, we might be able to hit the jackpot and get a lot of information about the system, about the network, and maybe even latest patches that have been applied or not applied. And we can use that information to take advantage of the host or other targets within the network. So this is the stage where we want to gather as much information as possible to determine what our next steps will be. And SNMP, if vulnerable, can offer a ton of information. SNMP is not a vulnerability that will allow you to run remote code execution, not that I know of, at least. But it will allow you to gather a lot of information so that maybe it'll lead to a remote code execution if that vulnerability is there. So as we do the example, I think that that's going to provide a lot more clarity on what we can do with SNMP and the type of information we can gather. So there are a couple of things to understand before we perform our SNMP scan. First, read-only and read-write community strings play an important role in what type of information can be extracted or modified on the devices themselves. So there's two types of community strings. One is private, the other one is public. Public, if I remember correctly, you don't need to have a password. It's just available. Sometimes you'll find that public with no authentication will allow you to get a lot of information on the network. And hey, read-only alone is already hitting the jackpot. Read-write, of course, allows you to read and also allows you to write or change the configs. So if you can guess the read-only or the read-write strings, you can obtain quite a bit of access you would not normally have. In addition, Windows-based devices are configured with SNMP, oftentimes with the RORW community strings. You can extract patch levels, services running, last reboot times, usernames on system routes, and various other amounts of information that are valuable to an attacker. By default, Metasploitables SNMP service only listens on local host. So if you were to do these examples with Metasploitable, which is the vulnerable Linux machine, you would want to go to this right here, and you would want to change this for this. And really the only difference is this right here. So you see how this has the local gateway. You would change it to just 0.0.0.0, and then you would reboot the machine and you should be ready to go. In this example, we'll do Windows together, Windows 7. If you don't have a Windows 7 VM installed, click on this video or on this video, whichever side it pops up on. And in less than 5 minutes, I show you how to install a Windows 7 VM. And then you can follow along with me for the rest of the video.
What is MIB? So when querying through SNMP, there is what is called an MIB API. The MIB stands for Management Information Base, and this is what we talked about earlier. This interface allows you to query the device and extract information. Okay, so this is the interface. The MIB API is the interface that allows us to query and get information, okay? Metasploit comes loaded with a list of default MIBs and that it has in its database, and it uses them to query the device for more information depending on what level of access is obtained. So let's peek at the auxiliary module, and that's the beauty of Metasploit, of all of these pre-configurations, of all of these scripts, of all of these default things that it has in its database that we can make use of by a few clicks, by just typing a few strings. So the auxiliary module that allows us to do it is the SNMP Login. Okay, so in this example, we're going to look for SNMP to find SNMP Login. Then we're going to do show options. We're going to fill out the required fields, which is probably going to be our hosts. Yep. We're going to set the thread. They changed the threads here to 10, from 1 to 10, and then hit run. And what we expect to get is some information on the console. So here it's telling it that, hey, for this IP address, we found a public string. And I guess it's giving more information on it. Embedded PowerNet SNMP agent. Right, so it's giving it information on the agent. Okay, cool. So here, as we can see here, we were able to find a community string called public. This most likely is read-only and doesn't reveal a ton of information. We do learn that the device is an APC Web SNMP device and what version it's running on. Okay, so let's look for this. So what is this, right? We need to be curious. So here we see that by connecting this card directly to the network, we're able to remotely monitor and control an individual UPS. So the UPS is the uninterruptible power supply. So if your power goes out, this will kick in, but you can monitor its status throughout while it's being used, while it is sleeping or resting. And you'll be able to do it remotely through SNMP because of this card being implemented in your network. So that's pretty cool, right? So just by doing this quick SNMP login, we were able to find out that, hey, they have an APC, they have an uninterruptible power supply, and we're able to see the version. Okay, so let's do this example ourselves. Let's do a SNMP login ourselves. So let's fire up our trusted Kali. Let me make this a little bigger. Now, first things first, we're going to need, besides the Kali, we're going to need a virtual machine that has SNMP available. If we don't have that, then we're in trouble. So I did a little bit of research and I found out that we can enable Windows SNMP on Windows 7. So if you have that machine, fire it up. And if you don't have it, then it's very easy to install. Just click on this video or this video wherever it pops up, and I'll show you in like less than 5 minutes how to install it, how to get it running. And then here we're going to fire that machine up and we're going to configure SNMP on it so that we can actually perform the exercises. So let's go to our Windows machine. Okay, so once you have your Windows machine, we're going to click on the Start button. Let's go to Control Panel. In Control Panel, let's go to Programs. In Programs, we're going to go to the second option at the top, Turn Windows Features On or Off. Now we're going to scroll down and we're going to look for SNMP. click on the plus sign and enable WMI SNMP provider. So let's press OK. Fantastic. We can get out of here. Now let's start the command line. Let's go to start. In the search bar, let's type command. Once the command prompt pops up, you want to right click on it. We're going to run it as administrator. Perfect. We get the command prompt here. So here, let's type services.msc. So the ServicesMSC is the Microsoft Management Console file that loads the services snap-in. It's used to administer Windows services. It provides a GUI to do things like start, stop, or disable services, change login context for services, set auto actions for services. So if you want to manage the services, you would go to services.msc. And that is exactly what we're doing right now. Notice that we fired it up. The GUI pops up right here. And what we want to do is we want to look for SNMP service. Okay, so here it is, SNMP service. Right click on it. Properties. Let's go to security. Okay. There's a few modifications we're going to do here. First things first, we're going to click on accept SNMP packets from any host. So we're basically telling this computer, hey, anybody sends you an SNMP packet, you accept it, right? The other option is accept SNMP packets only from these hosts. So it's basically creating a whitelist. And this would be more secure, but for our intents and purposes, we'll use this one right here, the first one. The next thing we want to do is here at the top, make sure that send authentication trap is selected. And we're going to add the community strings. And remember, the community strings are basically the authentication methods. So for read only, we're going to name this public. And then we're going to add another one, and we're going to select read write, and it's going to be private. Fantastic. We're going to apply it. Okay. Exit out. And boom, we're done here. Let's go back to Kali. All right, cool. So first things first, right? Let's do a quick if config. Okay, so this is my IP address. I'm going to copy this. And the reason that I want it is to get my network subnet. So this is going to be my subnet right here. So I know what to scan because I know that my Windows 7 machine is in my network, but I don't know what IP it has. So if you're in the network and you want to identify, okay, what machines are here, then you would want to get your IP and then get the subnet and then scan for the hosts within the same network. So this is our IP. We're going to copy paste this here. We're going to do a quick nmap. We're going to delete the last few digits and we're going to type 0/24, which is going to scan for machines from 0 or 1 to 255. So it found a machine. Found a machine right here. Notice that we don't see SNMP, right? But notice that all the ports it's showing is TCP because that's the default scan. So let's do another nmap. Now we know that there is a machine that's up. Or actually, we'll leave this here. And what we'll do is that we'll add, let's do an SU to look for UDP ports because SNMP works off of the UDP port. So SU161, which is the number of the port for SNMP. And I think that's it. So let's try that. We need to be root first. So sudo su, enter your password. Okay. Rinse and repeat. So I'm just going to copy paste this thing here. Okay, so I canceled the previous one because it was taking so long. So I'm just going to scan for the host that was discovered previously for the same port, 161. Let's do it. This should be much quicker. Oh, snap. Of course, it has to be port 161. Okay, let's go. Okay, awesome. There you go. That was super quick. So 161 UDP and it's open with SNMP. Perfect. Okay, so we have SNMP available now. Isn't that cool? All right, so let's fire up Metasploit. The TAC queue right here is just for quiet mode, so it doesn't print all the ASCII art. Instead, mine just gives me all of these horrible warnings, I guess. I don't know what this is, but as long as it works, we'll be fine. So let's search for SNMP. There we go. So it's going to give us all of the different options that exist. Remember that we're looking for SNMP Login, and this is defined as the SNMP Community Login Scanner. So let's get some info on 24. This module logs into SNMP devices using common community names. Okay, cool. So I guess that if you know the community name, it will be able to log in, and we can test that actually. So the way that we'll test this is by we're going to set the R hosts here, and then we're going to run it, and then we're going to go back to our Windows machine. We're going to change the community name and see if it finds it or doesn't find it, to see if that's what it's doing. So show options again. We're going to set, because we need to select it. Yeah, we're going to use 24. Show options again. We're going to set G, which is set global, and we're going to type in 168.100.12. Is it G set? Oh, set G R hosts. That should work. Perfect. Now let's run this. Actually, let's change threads to, let's do threads to 5. Let's run. Boom. So notice right here in the plus sign in the green, for the IP address at this port, right, which is the SNMP, login was successful, public, access level, read only. And remember what we configured? We configured public would be the community string name, and then the access rights would be read only. Notice here that it says proof, system description, hardware, Intel 64 family, Model 6, AT-AT compatible, software, Windows version 6.1 build, 7601 multiprocessor free. Okay, so it's telling us that it's a Windows machine. It's telling us, hey, there's a public string. So we get a little bit of information. Not much. We haven't gotten much so far, but we get a little bit. So to better understand what this does, let's go back to our Windows machine, and I just want to test this. So let's go to, I guess we got to go to the command prompt, right? That's where we did it. Right click, run as administrator. Let's type in ServicesMSC. Let's go to SNMP, right click, properties, security. So what I want to do is I want to edit the public one to say, I don't know. Okay. DP underscore, right? Destination pentester underscore public. Let's try that. Apply. I'm sure that won't be a common name. Okay, so let's go back to our Kali and then let's run this again. I want to see if it still finds it or not. Oh, notice what happened. So it found private. So I guess what it's doing is that it's doing a word. It has a word list in its database of the most used community names, community strings, and it's searching for those. And if it finds it, if it's in that list, it'll tell you. So notice that how we modified public and it no longer appears. However, private appears. And it's telling us that it's read write, and then all of the other information is the same because it's about the machine. So very interesting. So we'll do one more exercise, and we'll do properties, security, and we'll edit the private to be DP underscore private. So notice that just a small change like that can fend off some attackers. So now we're going to run this again, and it didn't find anything. Interesting, huh? Okay, so I'm just going to go and set these back to public and private because, you know, I want us to get information. It needs to be fun. Let's make this vulnerable. Vulnerable. Okay. Let's click OK. We're going to hit run again. We're going to get information, right, on the public string. All right, fantastic. That's what we want. Perfect. So let's go back to our exercise. So it says that as we can see here, we were able to find a community string of public. And yes, that's exactly what we were able to find as well. This most likely is read-only and doesn't reveal a ton of information. We learned what device is in there and what version is running, and so did we. We noticed that, okay, that Windows is running here. We know that it is Intel 64-bit, etc., etc. Okay, so now we're going to be introduced to SNMP enum. And it says that we can gather lots of information when using SNMP scanning modules, such as open ports, services, host names, processes, and uptime, to name a few. And that's a lot of info, right? Open ports, that means that services are running there, the services and their versions, the host name, which would be the net BIOS, that would give us potentially the OS, what processes are running. I mean, that's a ton of information that we can go off, do some research, and find some potential vulnerabilities and uptime. Using our Metasploitable virtual machine as our target, we won't be doing that. We'll be using our Windows 7. We'll run the auxiliary scanner SNMP underscore enum module and see what information it will provide to us. First, we will load the module, and we will set the R host option using the information stored in our workspace. Using host R, we'll set this option for us. Okay, fantastic. We don't have the PostgreSQL database running right now, so we won't do the host R, but we already set the variable as global, so that's no problem. So what we want to do is we want to look for SNMP enum. So search for SNMP enum. Remember that you have to be already in the Metasploit console so that you can search within it. So when we look for SNMP enum, we find this one right here. SNMP enum. Let me make this a little smaller. There we go. So yeah, so let's get some info on number 1. So it's going to give us the basic options. And then the description says that this module allows for the enumeration of any devices with SNMP protocol support. It supports hardware, software, and network information. The default community used is public. Got it. So it's going to get all of this information if you know the community string. Notice how it's set here. So if the community string is different to public, then you would need to put it here. If you don't know the community string, then there's nothing that we can do, because the way it gets access to this information is through knowing the community string. Okay. For ours, it's public, so we'll leave this here. Notice how we set our hosts globally by typing in set G and then putting our hosts and then the IP address. So it already pops up here, so that's super helpful. Any other required fields, our port, which is 161, threads is 1, etc. Let's just set threads to 5. And let's run it. So let's use SNMP underscore enum is number 1. So we're going to type in use 1. Make sure that it appears here within the parentheses. We're going to type show options. Our host is already set. Community string is public. Let's just change the threads. We'll change it to 5, and now we'll just run this puppy. Fantastic. Look at that. Okay, I'm going to make this a little smaller so we can get more info on the screen. But look at all this information that you get. This is a ton of info, man. So here's the IP address connected. Here's some system information. Here's the host name, John PC. That's it. Here's the description. Here's the OS version. You even get user accounts on it. Look at this. Network information. You get the network interfaces available on it. And it looks like it tells you if it's up or not. Yeah, down. Look at all this. You get the network IP. You get the subnet too, or the net mask. You get the routing information too. This would allow us to, this would help us pivoting. So this would tell us where can we pivot next from this machine, right? If we were to compromise it. We haven't compromised it yet. Remember that we are not compromising this machine. Right now, we're just querying for information. But this information is key and is going to lead us to a potentially exploited if there are any other vulnerabilities. It tells you where the listening ports are at. It tells you the services, network services running. If any shares are available. And the path. Storage information. File information. Device information. This is super, super good. Here's the processes that are running. So you want to potentially look for processes that could be vulnerable. Very cool. So this is a lot of info that we got. And all because SNMP was enabled and the community string was easy to guess. Because remember that if we look at the options, notice that we had to type in the community string. So if we go back to our Windows machine, and we edit the public one to dp_public. And we do the same thing for the private. If we hit run again, right? Notice that here we have set the community string to public. Nothing happens. There's no information. But now if you have the community string, and let's say that we say set community to DP public. Notice that it's set here. We're going to run this puppy. There we go. You get all the info again. Boom, chakalaka. All right, so let's go back to... Oh boy. My Kali Linux has pooped. So if we go back to the course, they hit run, and then they get all of the information that we got as well. The output provided above by our SNMP scan provides us with a wealth of information on our target system. Although cropped for length, we can still see lots of relevant information about our target, such as this processor type, process ID, etc. And that's it, friends. That concludes our Metasploit Unleashed course, I guess episode number 4, all related to SNMP. So I hope you enjoyed this. Leave me some comments if you did something differently, if something worked, didn't work, what your thoughts are. Just feel free to leave those in the comment section below. All right, till next time. Bye.